Hello there! Welcome back. This is lesson 3 in unit 4. Today we're going to talk about how to convert between moles and number of particles. So in the last video we talked about dimensional analysis and we briefly mentioned what the mole was. And so we're going to use the concept of dimensional analysis to work on all these questions. And so today we're going to work through some examples. We'll do 3 mole to particle conversions and then 3 particle to mole conversions. Okay. So in the last video we ended off with this. 1 mole is 6.022 times 10 to the 23 things. So 1 mole is 6.022 times 10 to the 23 things. So just like we know 1 dozen is 12 things, and 1 ream of paper is 500 things, because those are convenient to those things. Avogadro, this dude right there, said, I'm going to name a unit mole, totally not named after his favorite pet mole that was, doesn't exist, made up, but he said that's 6.022 times 10 to the 23 things. Okay, so before we get into calculations, I have a question for you. What do you get when you cut an avocado into 6.6 times 10 to the 23 pieces? You get a guacamole. Ha 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 ha. Okay. So let's jump into the first set. I'm going to go from moles to number of items. So how many apples are in 10 moles? So just like when we did the other day, or last video, we're given 10 moles. That's what we're starting with. And you put our given over 1. So you can abbreviate mole as MOL. It's not a great abbreviation, but that is there. Okay, so we want moles to cancel out, so moles goes on the bottom, and we're looking for apples. And we know in 1 mole, you have 6.022 times 10 to the 23 apples. So moles cancel out, and when you plug it into a calculator, 10 times 6.022 times 10 to the 23rd, you get 6.022 times 10 to the 24. Remember, your unit is apples. So it works just like what we did in the last video, but now the numbers look a little bit weird. And that's it. Okay. How many kumquats are in 8.1 moles? So there is a kumquat if you did not know what that looks like. So we're going to start with our given, which is 8.1 moles. Put your given over 1. So again, you want moles to cancel. So where should you put it? You should put it on the bottom. And we're looking for kumquats. So they go on the top. And we know that in 1 mole, you have 6.022 times 10 to the 23 kumquats. So then you're just left with 8.1 times 6.022 times 10 to the 23rd, which gives you 4.87782 times 10 to the 23, it's 24 rather, sorry, kumquats. But we're not going to write down every single one of those numbers. We're going to use significant figures, and so this has 2 sig figs, and so our answer should have 2 sig figs. So we're going to round that to 4.9 times 10 to the 24. Parts. Okay. Next, how many atoms of neon are in 3.2 moles? Again, the repetition of this should be helpful. We're starting with 3.2 moles. Put your given over 1. Now you want moles to cancel. Where do you put it? You put it on the bottom. And what are we looking for? What unit? We're looking for atoms of Ne. So atoms of neon. Again, in 1 mole, you would have 6.022 times 10 to the 23 atoms of neon. And so just to make sure we set it up correctly, moles cancel out. We're left with atoms of neon. And so you get 3.2 times 10, 3.2 times 6.022 times 10 to the 23rd, which gives you, 1.9 times 10 to the 24 atoms of milk. Okay. Now that's going from mole, starting at moles, going to number of things. So now I'm going to give you the number of things, and we're going to figure out how many moles that is. Again, it works the same way. So how many moles is 6.022 times 10 to the 23 turnips? So you're playing Animal Crossing and you're buying all these turnips Sunday morning. How many moles of turnips did you buy if you have 6.022 times 10 to the 23 of them? So this is your given or your known. So you take 6.022 times 10 to the 23 turnips. That is your given. What do you do with your given? You put it over 1. Now you want turnips to cancel, so you put turnips, that is your unit, on the bottom, and we're looking for moles. So we know that 1 mole is 6.022 times 10 to the 23 turnips. And so turnips cancel. You're left with 6.022 times 10 to the 23 divided by 6.022 times 10 to the 23. If you're doing this on a calculator, which you probably are, you need parentheses around this, and you get 1 mole. So you bought 1 mole of turnips. Just imagine the profit on that. Okay. Number 2, how many moles is 30.10 times 10 to the 23 onions? So they're like these weird math questions. You go into the store and you bought 30.10 times 10 to the 23 onions. So that is your given. You put your given over 1. Now, your given unit is onions. You want onions to cancel, so you put onions on the bottom. And we're looking for moles. Again, doing these questions over and over again, they're following the same pattern. So this helps a lot, doing it this many times. Onions cancel out. We know in 1 mole, we have 6.022 times 10 to the 23 onions. And so you are left with 30.10 times 10 to the 23 divided by 6.022 times 10 to the 23, which gives you 4.998 moles of onions. Okay. Hopefully you should be kind of seeing the pattern, at least when we as we move forward. There's 2 other types of conversion that we're going to go to, but it's the same kind of setup. Okay, here you have 7.436 times 10 to the 26 molecules of water. How many moles is that? So you're given 7.436 times 10 to the 26 molecules of water. So that is your given. Put that over 1. Now you want molecules of water to cancel. So molecule of water to cancel, so that goes on the bottom. And we were looking for moles, so that goes on top. Again, we know our known conversion factor, that in 1 mole, you have 6.022 times 10 to the 23 molecules of water. And so, no molecules of water cancels out. You're left just with moles, so we know that's good. And so you're left with 7.436 times 10 to the 26 divided by 6.022 times 10 to the 23. And that gives you 1, 2, 3, 5 moles. So that's how many moles of water you would have if you had 7.436 times 10 to the 26 molecules of it. Fun reminder, water looks like a Mickey Mouse. Okay, so just to kind of recap when we're going between particles and moles. When you're given number of particles, so say given number of particles, always put that over 1. And so when you're given particles and going to moles, you're always going to divide by 6.022 times 10 to the 23 particles. So when you're going to moles, you divide by 6.022 times 10 to the 23. But oppositely speaking, when you're given moles, so given moles over 1, and you're going to number of particles, we're going to multiply by 6.022 times 10 to the 23. Remember, your moles would cancel out, particles on top. So if you're given moles and going to particles, you multiply by 6.022 times 10 to the 23. So if you're going into moles, you divide. If you're coming out of moles, you multiply. And so, something my high school teacher shared with us, DEMO, which stands for divide in, multiply out. So if you're going into moles, you divide. If you're going out of moles, you multiply. So it's kind of that short 1-slide recap of all the questions that we did. So next video, we're going to take a quick break from conversions, talk about molar mass, and then in the following video after that, percent composition, and then kind of come back to more mole conversions. So there are 3 types of mole conversions in total. This is the first one. Again, the other 2 will follow the same 1-step pattern. So on that note, have a wonderful day.